Hi friends, my last tutorial seemed to be a hit with you guys, so I'm going to do it again. However, I'm going to do it a little differently. Before I dive into the question on our discussion questions, I'm going to do a little background on how we find vertical and horizontal asymptotes. For this example, I'm going to use the function f of x equals negative 5 over 3x minus 9. In order to find vertical asymptotes, the rational function must be in its simplest form. Then once it's in its simplest form, the vertical asymptote will be at the zeros of the denominator. What that means is that we set the denominator equal to 0. And when we do that for this problem, it would look like 3x minus 9 equals 0. We would add 9 to both sides and isolate the x, so divide 3 by both sides as well, where we get x equals 3. So our vertical asymptote will be a dashed line down where x is 3. To find our horizontal asymptotes, we're going to compare the degree of n of the numerator with the degree of m of the denominator. So in this case, we're going to look at our problem, our function, which is negative 5 over 3x plus 9. We see that there are no variables to any degree, therefore our n is going to equal 0. And if you look at the denominator, we have 3x. That really doesn't show anything above, but we're going to assume that it's 1 because anything to the power of 1 is itself, so m will equal 1. Now there are 3 rules when it comes to horizontal asymptotes. In this case, n is less than m, therefore y equals 0. So your horizontal asymptote will be at y equals 0, just another dashed line, like we see right here. But let's go into let's erase this for now. Let's go into the other rules, for example. So if we had negative 5x over 3x plus 9, we then could use this rule right here, because we would have 5x to the first power, 3x to the first power. They're both to the first degree. So in this case, you would take the leading coefficient on the numerator, which would be negative 5, and then we would put that over the leading coefficient of the denominator, which is 3. So in this case, we would have a horizontal asymptote at negative 5, 3, which comes out to negative 1 2/3. So it would be about right here if that was the case. It's not, but this was just an example. And let's say we had negative 5x squared over 3x plus 9. Then we would have a degree of 2 and a degree of 1. If n is greater than m, which in this case it would be, there would be no horizontal asymptotes. So you wouldn't have a dashed line at all right there. This is not supposed to be plus. We're going to fix that. 3x minus 9. Sorry, guys. All right. So now we're going to dive into our problem. I chose number 4, and that looks like f of x equals negative 3x plus 5 over 3x minus 9. So similar to our example that we just did, we're going to, this is in its simplest form. We can't really do anything else besides pull out a 3, but there's no point. So we're going to set the denominator equal to 0 and solve for x. So x equals 3. So our vertical asymptote will be at x equals 3. Now we're going to look at our horizontal asymptotes. With our function, we have negative 3x plus 5 over 3x minus 9. We're going to look at the second rule where the degrees are going to be equal. So if they're equal, we're going to take the leading coefficient of the numerator and put that over the leading coefficient of the denominator. We're going to simplify that, and it's going to be negative 1. So we're going to have a horizontal asymptote at y equals negative 1. And that's what our graph is going to look like. Now, to go into a little further detail, these asymptotes basically mean where our graph meets that point but never makes contact with that point. So it would look something, for example, like this. It would, like, you'd have your 5 points wherever, but it would never, ever, ever, ever touch the asymptote. And sometimes it'll be like right here too. And that's just where the graph blows up, so to say. So it'll get closer and closer and closer and closer and closer and closer and closer to 0 the more you multiply it, but it'll never, ever, ever touch the asymptote. It'll never get to that point. Or 0, I said 0, but it would be negative 1, or right here in your vertical asymptote, 3. It'll get so close to 3, but we'll never touch it. And that's pretty much it. Thanks, guys.